Site Standing Committee of IEEE Delhi Section, Region 10 of IEEE with the Associations of Computer Society of India, Institute of Information Technology Professionals IITP, ISTE Delhi Section, and IETE Delhi Center as technical collaborators welcomes you all to the IEEE IETE BVI Camp Technical Lecture Series on 6G enabled hyper-connected future. It is a moment of pride and honor to announce that we with united hands mark special contribution to the monumental occasions Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence as well as contribute our bit in seeking to find practical global solutions for the benefit of all. The aim of India during its G20 presidency tenure in 2023. This webinar is an initiative to mark both these monumentous occasions, Azadi Ka Amrit Mahotsav, as well as our G20 presidency. According to Samsung's 6G Forum, preparing for the future, 6G will bring huge changes to every aspect of our lives. This code showcases the capabilities 6G can harness. This webinar is aimed at providing a high-level overview of 6G for a hyper-connected future to the participants. As fifth generation 5G global rollout is underway, the focus of wireless research is increasingly shifting towards 6G. We expect that 6G will provide ultimate experience for all through hyperconnectivity involving humans and everything. Even though 6G is a few years away, it is already expected to take us into a world of seamless reality where the digital and physical worlds as we know them today have merged to trigger extrasensory immersive experience. Fast forward to 2030, and we are in a hyper-connected world that needs 1,000 times faster connectivity than what is possible today, with data transfer speed in terabytes per second and extremely low latency, allowing with response time in a few microseconds. In this session today, the speaker shall provide comprehensive overview of various aspects related to 6G, including technical and societal trends, drivers, use cases, candidate technologies, and research areas. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would now first welcome Professor M.N. Huda sir, Director, Bharti Vidyapeeth Institute of Computer Applications and Management, BVI CAM, and Executive Vice Chairperson, IEEE Delhi Section, to address the participants with his inspiring words.
Good evening, one and all. And am I audible, Dr. Ritika?
Yes, sir.
Great. So I take the opportunity at the outset to welcome my friend, Mr. Shubhankar Pal, Senior Director and Global Innovation Leader for Intelligent Networks Program, Cape Gemini Engineering, Gurgaon. I also take this opportunity to welcome my friends from various professional societies and especially my friend, Mr. Ajay, who has been a backbone for sustenance of this particular webinar series. Dear friends, we are grateful to our valued speaker, Mr. Shubhankar Pal today, who has very kindly agreed to deliver another session and that too on such an apt and futuristic topic of 6G, sixth generation enabled hyper connected future. Dr. Ritika has already briefed you that how the world is going to change and what the companies like Samsung and others are telling. So my dear friends who have joined from various parts of the country as participants of this webinar, you are fortunate to be part of this 126th series of the webinar, which is under IEEE IETE BVI Camp Saturday evening weekly webinar. And many other webinars have already been announced. Many are in the pipeline, which will be announced. So now almost on every alternate week from next week that is coming on 12th of August, we will be available with all of you with some or other innovative topic. This topic, 6G enable hyper-connected future, is going to become a reality, if not early, then at least by 2030. All of us know that in multiple ways we are using sometime 2G, sometime 3G. Now Delhi people are talking about the 5G from 4G. Now upgradation has happened. But believe me, the way Industrial Revolutions 4.0, IR 4.0 is going and entering into an IR 5.0, where primarily digital and the physical world is going to get merged. When digital and physical world will be coming at one platform, will be merged and will be seamlessly merged so that no fundamental differences will be visible to you. And when there is no fundamental differences visible to you, this implies at the back end for the network connectivity, the sixth generation network is working. When I'm talking of a sixth generation network working, then I'm talking of that network which at least from today's network will be 1,000 times faster. We know that around 2 decades ago, we have been talking about data to be transferred in kilobyte rates. We then started talking about data to be transferred into megabytes rate. Then we started talking about data to be transferred in gigabyte rates. And when the 6G enabled world will be coming, that seamless merger of the digital as well as the physical world will only be possible if we transfer data minimum with the speed of the terabyte rate. And when we are talking of a terabyte rate, you can imagine at what kind of a speed we are talking, what kind of experiences we are trying to give to the users. That is the futuristic hyper-connected world with which everything will come at one platform, and that probably जो धीरूभाई अंबानी ने स्लोगन रेस किया था, कर लो दुनिया मुट्ठी में, seamlessly will get realized. And that is where the change is going to happen. And that's how, my dear friends, I always say that there is nothing constant in this world except change. So let's change ourselves. Let's get ready ourselves to face that changes gracefully. Else, the changing ecosystem will change us. And that's how I always say that इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है. इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है, फिर भी परेशान क्यों रहता है? क्योंकि हम अपने आप को नहीं बदलते. एंड दैट्स हाउ अ ग्रेट पोएट सेड, ग्रेट पोएट गालिब सेड दैट उम्र भर गालिब यही भूल करता रहा, धूल चेहरे पे थी और मैं आईना साफ करता रहा. तो हम 6G के हाइपर कनेक्टेड वर्ल्ड को यूं ना समझें कि अभी मैं दिल्ली के 200 किलोमीटर बाहर जाता हूं तो 2G मिलना मुश्किल होता है. हम वो आईना साफ करने वाला काम नहीं करेंगे. हो सकता है कि ऑल ओवर कंट्री, that too in a diverse country like India, we may not be getting 6G, but at major cities we'll be getting 6G. And every one of them may not be using 6G, but at least those people who will be using, let's start believing in the positivity and in the positive contributions and the seamless experiences of the technology. इसीलिए मैंने कहा कि उम्र भर यही भूल करता रहा गालिब, धूल चेहरे पे थी. हम टेक्नोलॉजी के साइड इफेक्ट्स बताने में बिजी रहते हैं, लेकिन टेक्नोलॉजी ने जो एडवांसमेंट हमारे लिए ला कर दिया है, जो आज भी हम इन वन और अदर वे वी आर फेसिंग, and none of us can deny, even not even a layman can deny that he is away from the technology or not using the technology. So let's keep ourselves ready for that futuristic world, which is going to be said as 6G connected, hyper connected technological world, which industrial revolution 5.0 is going to seamlessly be presenting to all of us. And that is for what we all of us are here. And we have invited Mr. Shubhankar Pal to enlighten us, to tell us how industry is moving forward, to which extent the new and seamless experiences will be getting, and to which extent we should be optimistic about it. So thank you so much, my dear friends from all parts of the country and abroad who have joined for this session. Let's gear up to understand and get some benefit. I am sure that maybe 5 years down the line, when this 6G enabled hyper connected world will become a reality, will be the kind of prevailing ecosystem in the country and abroad, then probably will be saying that half a decade ago we had session on this and we were knowing that what changes, what transformation, what value addition it is going to give to all of us. With this note, I would like to conclude that keep learning despite disruptions. दिल्ली में तो अलर्ट जारी हो गया है कि आई फ्लू एंड कंजक्टिवाइटिस बहुत तेजी से फैल रहा, सो वो सैनिटाइजेशन वाला कॉन्सेप्ट वापस लाइए. कीप योर सेल्फ हेल्दी, कीप योर हैंड्स clean, keep washing your hand and mouth so that the conjunctivitis and eye flu remains away, and keep learning despite disruptions. And this webinar series is primarily to ensure that all fellow colleagues from all parts of the country and abroad are engaged, are busy in learning. And like every other Saturday, I would like to conclude on this note कि फूलों की तरह फिर खिलेंगे हम, फूलों की तरह फिर खिलेंगे हम, और अगले सैटरडे एक नए टॉपिक के साथ फिर मिलेंगे हम.
अगले नहीं,
थैंक यू
उसके
सो
अगले,
मच.
उसके अगले, क्योंकि आपने अल्टरनेटिव कर दिया है.
अभी अभी आगे दूसरी बता देंगे.
आगे हम ऐसी गप्पे मारने के लिए मिलेंगे, मिल सकते हैं. चलिए.
Correct, correct. So thank you so much. Wish you all the best. God bless you all. And over to you, Dr. Ritika, please.
Thank you, sir. Thank you so much for the motivating words. With this, we welcome amongst us our expert speaker for today, Mr. Shubhankar Pal, sir, with an e-bouquet.
हमारे बैकएंड पे बिल्कुल नई टीम ट्रेन हो रही है, तो वो एक दो बार में देखें आप. बुके आ गया, ई बुके आ गया हमारे पास है. तो थैंक यू सो मच.
Right, right.
With this, dear participants, Shubhankar Pal sir is Senior Director and Global Innovation Leader for Intelligent Networks Program in Cape Gemini Engineering. He has close to 23 years of experience in telecommunication industry, having worked with companies like Nokia and C. Dot before joining Cape Gemini. His interest areas include advanced network automation, optimization, and sustainability using cloud native principles and machine learning for 5G and beyond networks. In Cape Gemini, he drives technology product incubation, product strategy, and roadmap development, consulting and service offer definition for telecommunication and related markets. I now welcome our expert speaker to this session and would request sir to kindly enlighten the house. Over to you, sir.
Thank you, Dr. Ritika. And I will also like to thank Professor Eman Huda, Ajay Goel, and all the eminent panelists here for inviting me to speak at this webinar. I am. I hope I am audible to you properly, and my slides are also visible.
Yes, sir.
If not,
Absolutely.
okay. Thank you. Okay. So, as Professor Huda was saying, and like I just wanted to emphasize that mobile network is in heart of everything that we are doing today. We cannot think even for a short while that we are not connected to our friends and family wherever we are in the world. And 5G, which is just getting rolled out, is even enhancing the experience more with better connectivity, faster and high-speed data connections, more reliable communication. So 5G has already given us something that is helping us to define the new use cases. But the question is that is 5G enough, or is 5G the end of the road for mobile network? Did we get everything that we need through 5G, or there can be something beyond 5G also? And that is what the topic of this webinar is: 6G enabled hyper-connected future, where we'll try to have a glimpse of what is the next generation of mobile network will look like, if it is at all there, and why even we need this kind of next generation network, because how fast network we need. We have a very good speed in gigabyte per second in 5G already, and such a good reliability. Then why we need this connectivity? I think my sharing has gone. Let me share it again. Okay,
Yeah.
I hope it is visible now.
Yeah.
So that is what we'll see in next 40 minutes or so. And then if there's a question, please put in the chat and I will be happy to answer. So let's fast forward to say the year 2030 and see how this hyper-connected future actually looks like. So this is a picture that I have taken from one of the holographic video communication that Vodafone was testing some time back. And here, this little girl who wants to be who's an aspirant uh, sports person is meeting her um, um, the best sports person today she wants to meet, but she's meeting her holographically, but the experience is so real that it seems that she's meeting this sports person in the same place where she is. And for that you need terabytes per second speed of data communication. For example, like even for creating a hologram of 200 millimeter by 150 millimeter, you need a transmission rate of 7.2 terabytes per second. So you can imagine that for creating this whole person, how much speed of mobile communication that you need. Let's get to another example of hyperloops. Hyperloop, for example, the, the company Virgin Atlantic, and there are a few other companies who are trying to have the next generation of surface communication at the speed of 1,000 kilometers per second. Hyperloop is there for a while. Even I was reading some of the Asian countries like China and Korea. They are even trying to have the next generation of railway communication with a speed of 1,000 kilometers per second. So we're not talking about 1,000 kilometers per second or a hyperloop, which is even faster, which like more than 1,200 kilometers per second. Then think about how we can have a reliable communication there, because you know that mobile communication, it handovers from one base station to the other. So how fast this handover has to happen so that the communication is still seamless, and the person sitting inside these hyperloop pod, they don't feel that okay, they are in such a high speed communication that there are interruptions in the communication, right? It should not happen. Another example is from the agriculture world. So the drones have been the mainstay for many mm, large work that we do, and one of them is the agriculture. For example, like what will happen in the future is that human will not be required to spray fertilizers or pesticides in the large agriculture field, or even inspect the crops. The A swarm of drones. A swarm of drone is several drones which are working in coordination with each other to understand which is the area where pesticides have to be applied, or water has to be sprinkled, or if there's a damage in the crop, how they can address that together, not just one drone, so that they can address the large field, which for one drone is not possible. When they intelligently coordinate with each other, then absolutely it is possible. And there are many other swarm drone examples, like painting a big hoarding or a advertisement board where several drones are painting that board, and one part is painted by one drone. So this swarm of drones can do many amazing things, but they need to have that next generation communication to do that. Another example which has now have started become reality, and by 2030 it will be the mainstream in many big cities. These are called EVTOLs, or electric vertical takeoff and landing vehicles, which are also called air taxis. That means they are traveling somewhere 500 to 5,000 feet above the ground. They are like small helicopters, which are less noisier than helicopter, less bulkier than helicopter, and electrically driven, so they're not polluting the environment, and they can go from within the city or from one city to the nearby city, and take around a few passengers, like 5 to 7 passengers they can carry. And this is becoming another important way of traveling faster and in a more sustainable way. So these eVTOLs have already the testing is going on, especially in Europe and North America, and in by 2030 they say that it will be another very smarter way of communication within the city and much faster to avoid the traffic of the city roads. And finally, this is a very new use case that I just saw from an Ericsson website. I've just put it here for that reason. This is called the sixth sense. That means, say this a lady is driving or is riding a electric bicycle maybe, and then this is around the corner where it is not possible to see if the vehicle is coming from the other side. So it is called the around the corner problem. And thanks to the uh, high resolution and the accurate positioning that can be identified, this is a connected bike. So this bike can give its position back to the nearby mobile antenna, and mobile antenna can also get the position of this bus, and it knows that if this bike doesn't stop now, so there will be an accident. So what it will do is it will apply the brake automatically to this bike, and will not allow it to go, because it knows that if it goes here there will be an accident. So it will stop the bike there and then it will allow the bus to pass and the cycle to wait. And you can see this video in Ericsson's website, also very nice video they have created for this. This is called the sixth sense. That means the mobile network is sensing very accurately where you are, and then it is taking a decision on your behalf for safety and other reason. This is the case for accident avoidance in the corner of the road, but there are other such examples. This is called joint communication sensing. So what happened in past was the sensing and the communication, they were separate streams, always were researched and applied separately. For example, sensing was used for radars, like detecting those enemy aircrafts or drones and other flying objects. And communication was, and the radio network that was used for communication was mostly for the mobile and other wireless communication. But they were always separate from each other. The radars never used this communication technology of mobile network, and mobile network didn't use the radar-like sensing technology. Now, thanks to 6G, they are all coming together, so the communication and sensing can happen, and this kind of amazing use cases can bring in. So this is like the glimpse of what 6G or mm, the world in the 2030 will look like. And this needs a very different kind of communication that 5G cannot provide. So even if we are like talking about 5G and rolling out 5G in our networks, in our cities rather, but 6G, the work on 6G has started, because the industry has already seen that what we have today is not enough to address all the future use cases like the ones that we have discussed. And that is the reason that there is so much of work that has happened in 6G. You might have seen that government of India, especially Modi ji, had unveiled our 6G strategy with the Bharat 6G roadmap. So, I mean, everybody understands. Even this time, India is also taking a leadership role in defining the next generation of mobile network, because they know how important the 6G is going to be. So, let me go a little bit back. Let me step back a little bit and see how we have reached up to this point. Like Soda sir was talking about, like 2G, 3G, 4G, and 5G now. So let's see. I mean, how we reached here. So we are today in the 5G communication network, and there are three eminent themes of 5G, or three eminent use cases of 5G. One is to provide EMBB, or enhanced mobile broadband. That is to provide data speed in gigabytes per second, for example, 20 gigabytes per second. The other one is the ultra reliable low latency communication. It is to provide a communication with a round trip time of less than a millisecond. And the idea here is to support the use cases like autonomous car, which needs a very fast and reliable and low latency communication, so that they can take decisions faster to avoid any accident on the road while they are driving through busy city roads. Another one is a massive machine type communication, where we are talking about thousands of sensors, like how 5G can connect to the factories and other IoT ecosystems like smart cities, smart lighting, street lights, and so on. And thousands of those sensors are communicating with each other to realize that use case. So this is like what 5G is. But one interesting thing is that every generation of the mobile network is driven by some of the research and some of the things that's happening around that time. For example, one of the key things that 5G research brought in was the mobile edge computing. Like they brought the edge node for the low latency communication, or this Kubernetes or cloud native technologies that came in here, and that also helped in having the newer kind of use cases, because use cases drives the technology doesn't drive any use case, right? So it is the use case which compels to have a newer technology which can support them, and one of them is the Apple Watch or the wearables that came in. So that was all about 5G. But if I talk about like the previous generation, the dominant theme of 3G was the first time, apart from voice and video, the mobile internet came in, though it was in kbps, but it is the first time that we could enjoy a smartphone with a mobile network. In 4G we saw a true broadband with gbps speed, and this is the time when the smartphone and the concept of apps came in. So many of apps we have, and the true multimedia communication was possible. Then what is will be 6G? There's nothing like a 6G, right? I mean, 6G will be the standardization will start in next few years, and the actual 6G rollout will happen in 2030. But there are themes. We'll talk about these themes here, which is driving the 6G from the use cases that we have seen. So the use cases are getting defined. What is the next generation of applications that the human and the machines will have, and that is what is defining these themes. And these themes are then supported by the different research that is happening around. For example, you might heard about the Open RAN or the ORAN initiative that is revolutionizing how the next generation radio networks will be created in a more open and multi-vendor way. Then we are talking about the satellites, which are becoming the part of the communication. You have seen the genius Elon Musk putting satellites in the web. Even India was launching like close to 60 satellites of OneWeb recently through ISRO's launching capabilities vehicles, right? And then there are new materials and new kind of technologies are being researched, so which can make the network much more sustainable, less power consuming, and so on. So in short, every generation of the mobile network brought something newer, which provide a better user experience to humans and machines communicating with the humans or with each other. And there was some research and some of the use cases that was driving it. There we have some use cases for 6G already, and the research that is happening. We'll talk more about that. But these are leading to themes, but actual standard will take some time to come. Okay, so one important thing that I want to talk about also is that how these new generation of mobile networks are created. Many of you might have heard about 3GPP, but you don't know how the 3GPP functions. So 3GPP is a central body for defining the mobile standards, and it is not doing this in isolation. Rather, it is done through collaboration of many regional entities also. For example, like 3GPP will first ask, say, ETSI in Europe, or TDSU in India, or ATIS in North America, that what are the requirements that you are seeing for the next generation mobile network. And then the what they will do is they will get this the requirements from the regional bodies, then it will create the global standard, and then it will send these standards back to the regional bodies, so that they can then customize it as per the need of the standards need for the local geographies. For example, like 3GPP standards are then further customized for European requirements of by ETSI, ATIS, it does it for North America, and so on. So there are around 20 market representation, 7 regional partners, and 1,000 contributors, and they all define these standards, and the standards are then given to devices, the network, so that they can use this one. That is how these mobile standards work. Just wanted to give you a view of like how the standards they work. So given the journey of the 6G, where we are right now, so we are still in release 18, and the 19 has just started in, where 3GPP with its 5G initiative is still working on 5G advanced now. But there are some bodies like ITU which has started evaluating the 6G requirements, and but the actual specifications for 3G for 6G, which will be brought by 3GPP, will happen around 24-25. That is maybe from next year it should start, and the product launches will happen in 2030. So this is a indicative timeline of what and when this 6G will come in. So what are the technologies that are shaping 6G? So, so there, we talked about many use cases. So there are so many use cases. It is like not possible in this short time to talk about all the use cases here. But the important thing is that use cases are coming in different combinations, like the use cases that will enrich the human-to-human communication, or human to machine communication, or machine to machine communication, so on. And based on the likelihood of those use cases becoming reality, I have put the size of the bubbles. But the most important thing is what is happening with these use cases. It is evolving the 2D communication to 3D. That means you can see me, and you can listen to me in a 2D kind of scenario. But what about like I am present holographically in front of you? So that is a 3D communication that will happen. 2 senses, video and audio, to 5 senses, like even touch and taste and all those things will come in to have those 5 senses, from gigabit to terabit. That means can we have speed in terabytes per second to have this very fast and high speed experience for holographic communication, or for multisensory XR, or extended reality, and so on. And the latency from millisecond to sub-millisecond. So this is the evaluation path that is forcing the 6G to talk about these different requirements and how they can be enabled through the different technologies. So as I was talking about few themes in the beginning, so these are the different themes. I will not go through all of them, but few things like the new spectrum. So every generation of the network, you would have seen that a newer frequency range that is used. Why you need a newer and higher frequency? Because higher is the frequency, you are able to put more bits and bytes into that, and more bandwidth can be provided to the end user. That's why we're talking about the new spectrums. We are talking about integrating the satellites and apps and drones, so that we can have connection everywhere. I am on top of the mountain, or I am in the mid of an ocean. Wherever I can still be connected with the people on the ground in my home, thanks to the satellite communication. So there are several such themes that are happening. For example, the AI machine learning, matter heard about the generative AI, Chat GPT, and all. It's revolutionizing things. Like, so how they can help us to improve the communication further and make it more reliable. That is another important thing that AI native radio is bringing. So, and net zero operation, that means can we make the communication much more sustainable than what we have in 5G, less energy consuming, but providing the same kind of experience. So these are the themes that are coming in. As I said, that there is no concrete standard yet, but these themes are driving the research area that will finally form the standards. So a few things that I want to quickly touch upon is, one is the terahertz or sub terahertz frequencies. So you might have seen that till 2G, 3G, and 4G, we are talking about somewhere between 700 megahertz up to few gigahertz is what 4G provides. 5G stretches it a bit more and takes it up to like close to 4 gigahertz. But what will happen is 6G will go beyond 90 gigahertz into a few hundred terabytes. Terahertz. Some of this frequency are already made open by these spectrum distribution authorities. So the from 95 gigahertz to 3 terahertz, that frequency has been released for experimental purposes already. And you might have seen that some experiments already happening. For example, LG sometime back, they have tested a bidirectional communication through the terahertz frequencies. Nokia is also doing some of the work out there. So they have already started the work. But the problem with going to a higher band is that as you go in a higher band, so the amount of distance it can travel reduces. For example, if you're talking about terahertz frequency, it can only go few hundred meters, and the reason is that because of the fading that happens in the higher frequencies, they cannot travel more. That means you need to have more antennas, much more denser network, and that will need more energy to power them, more network management to manage this complex network. So as you are going to a higher frequency to provide better bandwidth, your network becomes denser, much more complex, much more energy consuming. How you deal with that, right? So there is a trade-off there. The second is there is a concept of cell-free network that is happening. So with a terahertz frequency, what happens is yeah, the beams will be much more directional. Like a torch, if you see, the beam is always in one direction. It doesn't spreads out. But in the older generation, what happened is the frequencies were smaller and it could spread out. So you should have a honeycomb kind of cell. So you are in a cellular network, and handover happens from one base station to other as you move. But this concept of cells will go away, and some of the research talks about like more beams, like from the base station you will have like torchlight like beams. It will follow you where you go, and it will connect you, and there's no requirement of the cells anymore, right? That's an interesting thing. We don't know whether it will finally realize or not, but with the MIMO and other 5G technologies, this already has started. The beam forming and beam management has already started. It can but cellular network is still there, but in the future they're talking about the cellular network always goes away and makes the network much more simpler. Another important thing is the non-terrestrial network. The terrestrial network is what we have today on the ground, right? But non-terrestrial network will have integration with many satellites, apps, and drones. So let me take a little bit of time to explain this. So you might have heard about these different satellites, especially the LEO has become very popular now, thanks to Starlink, your OneWeb, and other satellite companies who are putting satellites just a little bit above the Earth crust, around 300 kilometers. They are putting in. Sometime back, people could even see the satellite shining in the night sky, the Starlink satellite, because it was so near to the Earth's surface. So these are providing you communication where terrestrial networks are not there. For example, you are tracking on top of a mountain, or you are in a ship, or a cruise ship which is in the mid of the ocean. So earlier there was absolutely not possible to have the communication in those on those scenarios. But now, thanks to these satellites and HAPs are like the balloons, or some high altitude platforms which can stay there on the top for some time, say around few months, to provide you communication, and they are much closer to the earth than the leos, so HAPs are around 20 kilometers, so they can give you faster communication. So what happened earlier is satellites were not used because of their round trip latency. It took several seconds to complete this communication. It was not ideal for mobile communication, but thanks to these flying objects that are now very near to the Earth's surface, and hosting them there or putting them there is much more cheaper now. So these technologies are helping us to complement the terrestrial network and provide a larger, better network. For example, in iPhone 14, you might have seen that they have already started giving the emergency call through satellite phone, so satellite communication, right? So things have started already, but it will be much more seamless in 6G to incorporate the non-terrestrial network and complement the terrestrial network with this NTN functionalities. Some of the examples from NTN can be in the urban area. It can provide you communication where there are these terrestrial network is not able to provide. In rural areas, remote areas, isolated areas like ships or aircraft, they can provide you a much better communication. Another important thing, I talked about this sensing technology. This is a revolutionizing technology. This is called joint communication and sensing. So this is a little bit busy chart, but what you see here is what is the accuracy of the different technologies, or different generation of mobile network. Earlier in 4G and 3G, it was 10 meters and above, so they were not very good. They didn't have a very good sensing capabilities. That's why you used to always complement with other technologies like GNSS, or the GPS system, which is a satellite-based navigation system, which helps to create this positioning for us. But GPS has its own issues. For example, it works outside, it will not work indoor. It is not very seamlessly integrated with the mobile network and so on. Thanks to 60 terahertz communication, because the frequency is so high, so it is able to sense you. We saw an example of the round the corner use case, right? It can sense and avoid an accident, or it can sense and provide you the right kind of say instructions where you are. So there are so many examples of sensing that we have today, and thanks to this 60s near accurate sensing, which is less than 1 centimeter, it helps you to seamlessly work. So one ubiquitous technology can work in indoor, outdoor, and so on. Why? Because today what happens, in outside space you use GPS, indoor you use a Bluetooth or Wi-Fi. So there's so many technologies, and they don't seamlessly work across like indoor and outdoor. But thanks to 6G, the sensing capability, which is also called the sixth sense, will help you to have so many new use cases that will enable something that is not possible today. One last thing that I want to talk about is the reconfigurable intelligent services. So as I was saying, that each passing generation of mobile network is making the network much more dense, so much of energy consumption that is happening. So what they are doing is this is one of the important technologies 6G, where they're talking about reflecting surfaces, like these are new materials. So for example, this antenna has to communicate to these users, but there are trees in between, so it cannot directly communicate. It can use this reflecting surface, which can reflect it to the users, and the curvature can be changed through some software instructions also, so that the beams can be reflected in the right direction. But these are generally in passive device. They don't need any electricity to run this one. So this is a move towards a sustainable future, where we are reducing as many active devices as possible and bringing in passive devices like the reconfigurable intelligent surfaces, so that they can help you to provide the same kind of experience without consuming any energy out there. So so there's so many global initiative that is happening around, as I said. For example, the most important alliances that we have, one is in the North America called NextG Alliance, uh, which is all the North American research and industry which are coming in together to form the NextG. There's a NextG website, and there are tons of white papers and material that they have. You can go to their website and see what they are doing. So much interesting thing. And a equivalent of that is a HexaX, which is primarily a alliance of two big NEPs or equipment vendors. One is Nokia, another Ericsson, and then there are a few others who have joined. So they are also doing some interesting work in the context of Europe. And then if I talk about India, so India is also not behind, and thanks to the initiative from our government, and otherwise we have this Bharat 6G Alliance, which was recently being launched, where all the academia, industry, and the research communities in India are participating to create um, a kind of ecosystem for 6G to be launched and developed in India. And then we have a 6G body in India called TDSI, or there's a telecommunication standard body called TDSI, which is also actively working to define and contribute to the global 6G standard. Then there is so much of work that is happening in Asia as well, the other parts of the Asia, like I mentioned about LG testing something on the terahertz frequencies. Then you have Samsung, and the governments are there who are doing a lot of work. Another hub where the work is happening is around UK. In UK, there's so many, the academias are participating with industry to do some research. And in this context, I want to talk about what Capgemini is doing in this area. So we have been also actively contributing to the 6G research. And I just want to talk about this. So many things that are happening, but I just want to talk about two important things that Capgemini is doing, and these are all in the public domain. And I have put the link here. You can go and see that the press release that happened some time back. One is that we are researching on the networks. For example, like we are trying to see what is the next generation architecture that is required to support the 6G requirements. For example, the ultra low latency or extreme low latency requirement that they have. So we have already published one research or a scientific research paper that is already out. Another one we have submitted and awaiting a decision for that. But what is happening here with this research, we are trying to understand that what is this new network, which we call as the mesh network, coalesced RAN and mesh network, that is able to create a mesh-like topology to avoid any latencies that are happening inside the network to support the next generation of use cases. So this is one work that we are doing with King's College London in UK. So with partnership with that university, we are doing some fundamental research on 6G here. Another thing that is happening in India is we have in entire Capgemini, we are the first to launch a 6G research lab that will do fundamental research on 6G on these three themes. The next generation of simulations, because 6G as a network is not there, so you need a lot of advanced simulation to be done. Use the real 5G network to apply some of the advanced concept, like how you apply machine learning for the physical layer, and how you can bring the different constructs and processes for making the 6G more sustainable. Again, there's a press release that happened a few months back around this, and it was also part of our global India strategy that Capgemini has to push the 6G lab. So this is one of the, this is Capgemini's first research lab that has been unveiled in Gurgaon. And we are doing some fundamental research with partnership with academia, universities, and industry. So, and then there's so many other material that is already available publicly that we are doing. For example, we had a 60 week in end of April where we brought in some of the or invited some of the eminent thought leaders from the industry and from the academia to provide their share their views. So that was conducted by Capgemini. Then we have 60 point of view blog. Whatever I was speaking, that is all put together into a very nice blog. And there's so many other deep dive information that, and all of them I'm author already. So you can just see what we are doing. So while we are like working on the fundamental research in 6G, we are also like producing thought leadership articles for the community to benefit out of that. So in conclusion, what I will say is that though we are in early stages of 5G, 5G is getting rolled out, but given that 5G cannot support some of these advanced use cases, 6G has to come, and the work has already started, and the race is already on, as I will say, right? So it is like 2030 is when we see this inflection point will happen, and we'll see the 6G getting rolled out. But we are closely following and participating as Capgemini, as India, as a country. I mean, we are not behind. We are uh, uh, quite ahead in this race, and we are contributing to make sure that India is kind of leading in this 6G initiative. With that, I will stop. If there is any question, please let me know.
Thank you, sir. Thank you for this wonderful presentation. Yes, there are many questions which I'd like to take up now with your permission.
Sure.
Uh, yes, sir. So the first question we have, at the moment, 6G cost is a concern. So as a country, if we talk about India, how are we going to overcome it?
It's a good question. So 6G, as I said, is in a very initial stage. So we don't know how much it is going to cost. So that is why, like if you've seen this Bharat 6G initiative, so it has been developed in a public-private kind of partnership, and for that, developing the ecosystem is so important, right? If there are only few, say, equipment manufacturers and there are only few operators who are driving it, then surely the cost is going to be very high. So 6G from the very beginning by design, we want to make it more sustainable not only to make it energy efficient or having a better net zero possibility, but it's also about things which are cheaper, more affordable in an India context. And that is why the ecosystem of suppliers and the alliance that will make it much more sustainable in terms of developing, delivering, and putting it together is important. That's why the Bharat 60 alliance in context of India is so important, and such alliances are happening worldwide to make it much more affordable. So yes, I mean there will be a concern for the expenses, increase in expenses 6G will bring in, but with this initiative, I'm sure this can be addressed in future.
Yes, sir. So the next question we have, what would be the spectrum and license for 6G, and like what will be the bandwidth and frequencies it is going to use?
Yeah, as I was mentioning in uh, my presentation. So while 6G will also use the older frequency band. For example, like you might have seen that 5G is using the 4G bands and 3G band, of course, with the different modulations, but they will use the same band, but they will also use some of the higher bands like the sub terahertz and terahertz frequency band they will use, which are generally used by military and defense now. So some of them will be like taken from defense and given to public communication, and the terahertz frequency will provide you the higher bandwidth. So terahertz frequency with with terabytes per second. So that is a TBPS. From GBPS to TBPS is what we are looking for. So in terms of bandwidth, we are talking about TBPS. In terms of frequency, we are talking about using the current bands, and on top of that, some of these sub terahertz and terahertz band. But as I said, that this is very initial days of 6G. The vision is to use terahertz band, but how feasible and how practical it will be, only after a few years will come to know.
Absolutely, sir. I think that is very rightly said. But with this session, we have a number of inquiries that have been generated. So the next question we have, what about the 6G SIM? Will it be an eSIM or it is going to be physical as we have of now?
Yeah, that's an interesting question. As you might see, that eSIM has already started becoming a reality. For example, if you take an iPhone in US, there is no slot for a physical SIM. India still we have a SIM. So I think that eSIM is becoming a reality, and it gives much more flexibility and ease of use. So eSIM is a technology that is also evolving in parallel. Again, as I said, 6G is a very in its very initial days now. But I think with this progress that eSIM is making, maybe that eSIM will be the de facto way of connecting to the operator network in 6G.
Absolutely, sir. Please also do shed some light on the security issues that are going to involve 6G or let's say 5G beyond.
Yeah, okay. So the security is absolutely a very important thing in every generation of the network. One thing that will happen in 6G is we'll see the introduction of quantum communication or quantum computing, for say. So I didn't touch upon here because it's another very heavy topic. And one of the what this quantum communication is going to do is that it will create this encryption of this the communication network in a way so that it is very hard to decrypt, thanks to this quantum computers. Today the threat is that mm, uh, all the encryptions and the cryptography that we know, they work on a principle that uh, um, with the today's computers, they cannot be decrypted. It is not possible to do it in a finite time. But given the quantum computers, which are much faster than today's computer, it will be easily decoded. So we need a different kind of encryption and different kinds of cryptography and security measures that is required with the quantum era. And that's why this quantum communication is another parallel thing that is trying to secure this one. So this is one thing that I want to highlight. Of course, there are other things that will also come, but this is one of the prevalent technology, I feel, that will address the security space.
Absolutely, sir. I think we'll have a number of questions, but then it would extend the time. We'll end it with one last question. Who is going to define the 6G standard and how is it going to reduce the carbon emissions?
That's again a good question. So as I said that of course it will be defined by the 3GPP body, but as I said that 3GPP is the main standardization body for the mobile communication network. It has been doing it right from 3G, 4G, 5G, and now advanced 5G, that is release 18 and 19. And it will keep on doing. So they are saying that from release 20 onwards, it will be like the embarkment to the 6G era, and 3GPP is going to do that. But as I said, it doesn't do it in isolation. It works with the regional bodies like ETSI and North America bodies, Asian bodies, and it gets the requirement from those regional bodies. It creates a global standard, and then it distributes the standard that are further customized by these regional bodies like ETSI. So this is a very interesting ecosystem of how standards are created, distributed, used, and and from the industry they get the feedback to evolve it further in the next releases. In short, 3GPP is the body, but it works with the regional bodies to make it much more robust and much more usable in a regional context.
Yes, sir. Thank you, sir. Thank you so much for this wonderfully informative webinar today. With this, we come to an end to this wonderful session. I would now request Professor M.N. Huda, sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, BVI CAM, and Executive Vice Chairperson, IEEE Delhi Section, to kindly present a certificate to Shubhankar, sir, for this wonderful session.
Thank you so much, Mr. Shubhankar. And as usual, the talk has been fantastic, and probably 5 years down the line, when its penetration will be visible and people will start talking, they will remember our webinar and will remember you. This certificate is only for remembrance of that day, that when it was in the phase of infancy, we deliberated on this and was useful. So thank you so much, Mr. Shubhankar. And dear participants, recording of this webinar is available through our YouTube link to all the participants, those who missed or those who wanted to view it again, or any of our prior webinars. Close to 500 such technical sessions are available. The link of that I am sharing. So please subscribe that YouTube channel. There will be 500 plus such sessions available, which is a huge repository in itself. And this memento again in e-mode. You might have observed, Mr. Shvankar, we have shifted from the hard copy of the certificate to the e-certificate, from the hard copy of the memento to electronic memento, and at the same time, the actual flowers to the e-flowers. This is all part of sustainability, and probably will fit in the domain of that hyper-connected world as well. This webinar itself is part of that hyper-connected world. So thank you so much. We'll meet again with some new topic, and we'll be again connecting for that purpose. And thank you so much. Dear participants, this meeting room is now converted to a facilitation center where feedback link is being shared now. So fill up the feedback link so that your certificates can be generated. If you do not fill up the feedback link, our team